Continue with solution and concentration. The concentration of solution is molar M and is mole over volume V. The unit is mole over the m cube or millimole over cm cube. M molarity, M molar is mole. Mole is mass over mr or AR divided by V volume. We can convert N as molar times volume. For example, here calculate the concentration of sodium hydroxide NaOH 250 milliliter cm cube, but the question is in the m cube, so we convert the cm cube, the volume, to the m cube divided by 1000. Then the molarity is mass over mr. The mass is 2. Then mr is 40. So this is the mole. The mole is 0.05 divided by the volume in the m cube 0.25. So the concentration is 0.2 mole per the m cube. Another example, calculate the mass of anhydrous copper to sulfate. Copper to sulfate, CuSO4. Anhydrous without water here. 55 cm cube. We convert into the m cube divided by 1000. Then we use the formula N is molar times volume. This is the molarity. (0.20) times the volume in the m cube. So you get the mole, and then you can find out the mass by multiplying the mole with the mr. So you have the mass. Continue with molar gas volume, the volume of gas. There are several conditions here with symbol RTP, room temperature pressure. 1 mole of any gases occupied volume 24.0 dm cube. When STP condition, standard temperature pressure, 1 mole is 22.4 dm cube. Or we don't know the pressure, or we don't know the temperature, but there is information about one particular gas. For example, oxygen in certain temperature and pressure. For 1 mole occupy 20 dm cube. Then we can find out for H2, the volume of H2 for, let's say, half mole. So half mole of H2 will have the volume of half times 20 dm cube. That's 10. Or we have the information of pressure and temperature, but not at ATP or STP. For ATP, the temperature is 25 degrees Celsius and 1 atm of pressure. For STP, 0 degrees Celsius and 1 atm of pressure. We have the information of pressure and temperature, but not 25 and 1 atm or 0 and 1 atm. So we use the ideal gas law. PV equals nRT. R is the constant of gas, ideal gas 0.082. And N is the number of mole. Another example here. Calculate the volume in the M cube occupied by 26.4 of carbon dioxide CO2. We find out the MR. 12 plus 2 times 16. That's 44. So, from 26.4, we calculate the mole and its mass over MR. If we calculate, then we have 0.6 mole of CO2. Here, the condition is RTP. In RTP, 1 mole occupy 24 dm cube. So for 0.6, is 0.6 over 1 times 24 dm cube. That's 24 times 0.6, 14.4. Number B, a flask of volume 120 cm cube is filled with helium gas at RTP 24. Calculate the mass of helium present in the flask. We find out the mole by comparing the volume. We convert this to the m cube. Divided by 1000. So you get 0.120 dm cube. In RTP, 1 mole is 24. So the number of mole is this one. And the mass is N times MR, AR. Because helium is an element, so this one is AR. The AR is 4. So mass is mole times AR. The result is 0.02 grams. Next example, when 50 cm cube of propane reacts exactly with 250 cm cube of oxygen, 150 cm cube of CO2 is formed. First, we have the reaction of propane with O2 to produce CO2 and H2O. Propane. Let's say we don't know the formula. We just use the ratio of the volume, 50, and then 250, exact. So this is the ratio, no excess. And then producing 150. So the ratio of propane, O2 and CO2 is this one. 50 to 250 to 150 cm cube. So the ratio is 1 to 5 to 3. So 1 molecule or 1 mole will react with 5, producing 3 mole. If 1 molecule react with 5 molecule, producing 3 molecule. So we have the coefficient here, but we don't know the number of hydrogen. The number of water. We can calculate here oxygen on the left hand side. 5 times 2 is 10. From here you have 6. So here lack of 4 oxygen or 4 H2O. So there are 3 carbon and 8 hydrogen. So the molecular formula is C3H8.